Okay. Thank you very much, y'all, for inviting us and accepting our talk. It's fantastic to be guest at the Jacksonville Java User Group. Thank you for joining, everybody. This talk is all about ultra-fast Java in-memory database apps and microservices, pure Java. How you can build super fast database applications with pure Java. So I have some problems with my presentation, but now I think it works. So my name is Marcus Kett, and I'm CEO and co-founder of MicroStream. We are also contributor to project Helidon, so we are very proud of being part of this fantastic open source project. I'm also editor-in-chief for the Java Pro magazine in Germany. It's actually a German Java magazine, but next month we're gonna start with an English online edition also. In Germany, it's also a printed magazine. We are also organizer of the JCon conference that is actually located in Düsseldorf, Germany. But during the COVID pandemic, it became a virtual conference, and this was actually an advantage for us because the conference is now growing more and more international speakers, more international participants. More than 2,500 participants joined the conference last year, and next JCon conference will be in October. If you want to join the conference, it's free for all Java User Group members. And together with Florian, who is our CTO, we developed Java IDEs and APIs for almost 20 years now. So we started with our first Java project was a web design software. I think it was the very first web design tool written in Java and based on Java applets. Then we developed it to a Java development environment, and there our goal was and our dream was to make Java available for all 4GL developers, people who wanted to migrate their Oracle Forms applications or Visual Basic applications, Microsoft Access applications, FileMaker to Java very easily, because these guys they know they have legacy applications and Java would be the better choice, but for them Java is mostly too complicated, and so they are looking for a tooling that works similar to their 4GL development environment. But based on Java. So this was our idea actually previously, to realize that we built up GUI builder based on Swing, then code editor, we used the Eclipse compiler, and built a beautiful IDE. But the problem was persistence. So as soon as the developers wanted to store some data, they were in trouble. Then some years later, we migrated everything to Eclipse, and now this project is called RapidClipse. It's open source. It's a free development IDE. It's a kind of like Java it's a kind of like Visual Basic for Java. So it's also free. And the framework is open source. And we have worked many years on the JBoss Hibernate tools. And this is very important for me to to mention that we spent many years on JPA, on Hibernate, improving the tooling for Hibernate. We wrote a new kind of like query language. It's called JPA SQL. It's also open source to enable the developers write SQL code and create JPA criteria code as an end result, to improve and to simplify database programming in Java. But the problem was it's still too complicated. So our users say, it's too complicated, and the database applications are mostly too slow, and you always have to develop your business applications around the database, and this is very annoying. And so the question always was, is there any possibility to improve and to accelerate database development in Java? And this is the reason why we tried out completely different approaches. And so I like to talk a little bit about what was actually the problem for us with traditional persistence approaches, especially for Java. And then I like to talk a little bit about a different approach. It's called system prevalence, pure Java in-memory data processing, and how powerful Java actually is right now, and how can we use the performance of the JVM to accelerate database access and to build up super fast and really incredible fast in-memory database apps, and also microservices with pure Java. And then I like to introduce MicroStream, the project we are working on. This is an open source project, and you can use it for persisting all your objects, any object persistently on disk. I will show you a small demo. Here you can compare a traditional database app written in Java and based on JPA Hibernate and EH cache in comparison to this system prevalence approach. Florian will show you some code, and of course we will have some time for Q&A. And if you have any questions, you can interrupt me anytime. You can use your microphone, use the chat, and I don't want to bore you with things you know already. So if everything is clear for you and we should go on a little bit faster, then you can also interrupt me. And if you have a different opinion, of course, it's always interesting to hear what you guys think about our experience and our approaches, and what we tell and explain about persistence for Java today. As I mentioned, MicroStream is now open source. We have open sourced it last year, and Oracle has included MicroStream into Project Helidon. The code is available on GitHub. So if you like it, then please start us on GitHub. So this is the best motivation for open source developers. Of course, you can download MicroStream via Maven. It's it's a tiny Java library you can include in your all of your Java projects and microservices. MicroStream is part of Helidon, and currently we are working on integrations for other microservice frameworks like Quarkus. So we are working on a Quarkus extension, and we're working on a Micronaut extension. we have included an extension for Spring Boot into MicroStream already. And our goal is to become integrated with all the major microservice frameworks. Why? Because we think MicroStream is a kind of like micro persistence. It's super fast and fits very, very good with microservice frameworks and microservices in general. But it's also suited for traditional monolithic applications. Here is our advisory board. So we have really great advisories. We are working together with Adam Bean, Steve Poole, Sven Ruppert, and Yolande. She's very famous in the Java community, built up the Java the Java Twitter account. Now she's working for Neo4j, and so we are very proud that we can work together with these great people. The MicroStream history started in 2013. The development started in 2013. Then 2 years later, we used MicroStream in the first time in production, in a very important project. And then we made a decision. So we have to build a product, but it took some further years to build the company and then to open source the code. So currently MicroStream is funded. So we have completed 2 venture capital rounds. So this is the usual way to finance open source development, and then hopefully someday earning money with great open source software. Our partners are Oracle, so we are contributed to the project Helidon, mentioned already. We're working together also with the IBM team, the Open Liberty team at IBM. We work together with the Payara guys. So this is really great cooperation, and also with Azul, because we recommend the Azul JVM if developers think about using huge memory sizes and have concerns about garbage collector pauses. And with the Azul JVM, we have great experience. And so this is also the reason why we work together with Azul. And we also deliver some additional value to the project and for our users. In terms of we are the main contributor, we provide a large test coverage and provide update warranty for the open source project. Okay, let's get started with traditional Java persistence. And I like to talk about our experience. So why traditional Java persistence did not work for our customers very well. So normally we have Java applications, so the business logic is written in Java, of course. We have a monolithic application or a microservice written in Java. Then we have our objects, and in best case, we have an object graph or something like that, and the JVM, of course. Today, or I guess since more than 30 years or so, the most databases used out there are the relational databases. And the problem here is everything in Java is an object and everything is object oriented. But as soon as you want to store data persistently on disk, then you have to use a relational database, and then you have to store data in tables. And storing complex object graphs in tables is actually not possible from a technical perspective. So we have a problem here. And I would say this is a technical break. So it's a hard break. And this, I would say this is the the core problem in database programming in all object-oriented programming language.
Marcus, can I interrupt you for a second? Do you mind clarifying what is an object graph?
Yeah, if you have a complex or a more complex object structure, like all your objects are connected. You have, for instance, you have an online shop, and then you have customers, then you have articles, orders, and the articles belong to your order. The order belongs to a customer. So all of your objects are connected, and then you get an more or less complex object graph. And sometimes, or very often, you have circle references. So connected objects like a tree, for instance. So like a tree in Java Swing, for instance. And this and to store complex object graphs, this is always tricky to store complex object graphs in flat tables, because we have several impedance mismatches here. So it's for instance, the object model is much more granular than tables. Then subtypes, for instance, are not supported in the relational model. So we have several problems here. You cannot, or through an object graph, you can navigate through an object graph, but you cannot navigate through a table structure. You need SQL joins for that. Then we have many data types in relational databases. In Java, we have only a few primitive data types. In PostgreSQL, for instance, we have, I guess, 41 different data types. So we are forced to map these database-specific data types to Java types. I sometimes compare it with you want to translate a language. So you want to translate some text from Bavarian slang to English. So mostly this will work, because sometimes the words are comparable, but sometimes there are some words there is no good translation into the other language. So then you're in trouble. What will you do? So this is pretty much the same when you want to store complex object graph into tables or into any other database specific format. And yeah, I think this is the core problem, because we have to fix this problem. The question is, are the modern NoSQL databases, are they better? And I would say they are different, because they provide different data structure or formats, but they are not better because all of these data structure are also incompatible with Java object graphs. So we have the same issues here as well. And it's the same thing with in-memory databases, distributed caches, event streaming platforms like Kafka. No matter which storage technology you use, all these storage approaches provide data structure or formats that are completely incompatible with Java object graphs from the technical perspective. And so in all cases, you have to fix this problem. And we fix this with a mapping. So we have to map our objects to the database-specific data structure or format. And for the relational databases, we have object relational mapping. And the leading framework here is, of course, Hibernate. The standard is JPA, Java Persistence API. And if you use a NoSQL database, then you have, you need a custom mapping or converting data into a database-specific format, like JSON, for instance. But what's the problem with mapping? It's kind of like data conversion behind the scenes through every single read and write, and this is very expensive. And this is the reason why database queries are mostly that slow in Java, because we have an object relational mapping behind the scenes, data conversion, so we have to generate SQL, or the framework has to generate SQL code, and vice versa. The database sends a result set to the application, and then the object relational mapping framework has to generate objects again behind the scenes. And this takes lots of computing time, and it leads to latencies and slows down our queries. Mostly, the application cannot be used anymore because of this object relational mapping, and the performance goes down. So it can't be used anymore. It's too slow. What can we do? We add a local cache to store result sets we receive from the database. We store the result sets in the memory because memory is super fast. Access to the memory is up to 100,000 times faster than access to our hard disk drive. So yeah, let's use in-memory computing, and let's use a local cache. So this is a good chance to accelerate our queries. But as we can see on the screen, we have another layer. So we have a object relational mapping framework. Then we need a caching framework. You have to include this. You have to configure a lot of things. So your database application gets more and more complex. And also, if you write a microservice, so actually a microservice should be tiny, should be less code, and should be really small. But as soon as you want to store data, then you have to add a lot of things, and this is your application or service gets more and more complex only for storing some data. This is not convenient. And I mentioned it already. Mappings requires lots of computing power. It slows down your queries, and also is responsible for that your infrastructure costs increase more and more because you need more and more CPU power or additional CPU power to keep your application running. In the cloud, this is not a problem because, hey, if you have not enough performance, then, hey, let's copy the machines, right? But yeah, you can do that, and we can scale horizontally. This is very, very popular in the cloud, but your costs will increase also. So this is sometimes, or it's mostly the reason why the cloud costs increase more and more. But this is very common today for developers. This situation is also very challenging because you have to deal with two completely different data models. You have your Java classes, you work with objects, and on the other hand, you have to deal with database-specific data structure or formats. You need a data type mapping. You have to deal with complex frameworks. You have, you add an additional caching layer, which is complicated. And at all the Java conferences, we have the talks about caching and misunderstanding concepts about caching. How does it work? How can we solve this? So very complex for developers and only for storing some objects. So this is perhaps not really cool for developers, but it's a standard. It's the way to go. How we do it today. And in Wikipedia, I found this article that describes the situation very good. The article is called "Impedance Mismatch," and as soon, as long as as the systems are different, then you will have these problems. So the performance goes down more and more, or your architecture and your application becomes more and more complex. So you cannot avoid this. So actually, we should fix that core problem. But no software engineer will work on a core problem. We actually copy the machines, and that's it. So this is the reason why we were looking for different approaches, and the question was, the big questions, are there different approaches? Yes, there are very interesting different approaches, and many Java developers have tried this approach. It's called system prevalence. What's system prevalence? A prevalence system is a very simple architecture concept. You keep your objects in memory, and you keep your entire system state in memory. And by using snapshots, you're able to store the entire system state persistently on disk. And so with this approach allows you to process data completely in memory with pure Java and persisting your objects simply by using snapshots. This is a very primitive approach, but it's focused on high performance. So everything can be executed in memory with pure and can be written in pure Java. No more database specific data structure or formats. No more mappings at all. And the end result will be a super fast Java application. What do you think about the system prevalence approach? Let's have a look on the architecture. This is very simple. You have your app or microservice written in Java. You have your object graph in memory. You can query your object graph with Streams API. So all your searches can be executed in memory with streams super fast, and the streams are mostly executed in microsecond. So you get microsecond query times. Sounds really great. And to persist your system state, you use Java serialization. Looks simple, looks primitive, and has lots of disadvantages. So with this approach, we're running many challenges. And here's a list of the challenges. So snapshot size can be too big. Snapshot time can take too long. Then to use snapshots, perhaps this is not really suited for microservices, because if you have to reload and restore the system state, it takes too long. So with microservices, we need super fast startup times, and this is the reason why we can't use the JVM for microservices. So this is the reason why we have to use GraalVM native images to accelerate the startup times for microservices, right? And so this approach is not really suited for microservices. And then we have also problems if we have huge database sizes. So the database size is actually limited to the RAM size. Then the traffic can also be a problem. And if you have huge memory sizes, then many Java developers have concerns about garbage collector pauses. Then there are a lot of unanswered questions like, what if my class is changed? So how can I handle the class changes? And a lot of things more. The list goes on and on. And then Java serialization is also known as slow and insecure. And how can administrators get access to the storage data? How can I migrate the data? Lots of problems. So the initial system prevalence maybe works for smaller projects, but perhaps not for today's big data projects. And perhaps this is the reason why system prevalence is not that popular that it could be. In MicroStream now, with MicroStream, we have eliminated now all of these disadvantages. This is very interesting. Then we use the pros of system prevalence and we eliminated all of the cons. And this is actually what we did with MicroStream, Java native persistence. And so the question is, what actually is MicroStream? It's a Java native persistence. What does Java native mean? It means that we store native Java objects as they are in the memory, exactly as they are in the memory. We store these objects on disk, so no more mappings of Java objects to any database-specific data structure or any other synthetic data structure. And this persistence layer runs within your Java application, similar to Hibernate, and it enables you to store any object graph. You can store only one single object, but you also can store a huge and complex object graph with circular references, but you also can store only single subgraphs and restore all of this in the memory at any time. You can store it into any storage strategy or any storage technology. And vice versa, it allows you to load the entire object graph or only subgraphs dynamically into the memory. The loaded object references are then merged into the object graphs automatically, so you don't have to deal with object copies. And MicroStream itself is a tiny Java library you can download via Maven and include in any Java project. The architecture is also, in comparison to system prevalence, very simple. So you have your application or microservice written in Java, you have your object graph in memory, then you have MicroStream as a persistence layer, and it runs on a JVM, it runs on Gravian native images as well. And then you can choose any storage technology, you can use plain files, you can use a relational database, you can use any NoSQL database, because we store binaries only. This is the reason why you can use also a relational database without any mappings. So relational database, plain file storage, or NoSQL databases, or also you can use an in-memory database. You can store your objects also in Kafka or in a in-memory data grid. So it's your choice. So we read the objects from memory and we store it as it is into the database or into the file storage as a binary in a binary format. And to do this, we also use serialization. However, we do not use the Java serialization for that because it's not really suited to store and reload subgraphs. It's not possible to merge the subgraphs into the object graph. So this is the reason why we have written a completely new serialization from scratch. And so MicroStream bases on a completely new written serialization. The end result is a simple architecture, no more mappings. All your queries are executed in memory. You can use Streams API for that, microsecond query times, super fast queries, and in terms of CPU power and infrastructure costs, really our customers save up to 90% cost of infrastructure, and this is not marketing, blah, blah. This is really true. MicroStream is not only a serialization. Serialization is the core. On top of the MicroStream serialization, we built this persistence library for the JVM, and we have also an implementation for Android. So you can use it on Android as well. Then on top of that, we provide we call it a legacy type mapping. So this function cares for you for class changes. So if your class changes, then you don't have to care for that. MicroStream cares for all these of your class changes. We added a file system garbage collector. It works similar to the garbage collector of the JVM, but it operates on file base, on the storage. And we added a file system abstraction, so your persistence layer can be almost everywhere. It can be outside of a container, for instance. Then we added some database connectors that you can use, not only plain files, that you can use database systems as well. We added a REST interface that allows you access to your storage data, and then on top of this REST interface, we provide a graphical user interface that allows you to browse through your storage data. And then we added some native backup functions, and all of this is MicroStream. It's supported database systems right now, and other database systems or database connectors are in progress already. And MicroStream runs wherever Java runs. The only requirement really is Java version 8 or higher. I mentioned already, it runs also on GraalVM native images. You can use it with Java and all JVM languages, and runs on Android as well. So how does MicroStream work? It's really simple to implement MicroStream. It's incredibly simple. Here we can see a class, and what we see here is nothing specific. So you don't have to use any specific MicroStream annotations. You don't have to use any. Don't have to implement any specific interfaces or use any specific super classes. Just use POJOs. That's it. Really simple. You can use also, or you can store objects from third-party libraries very easily. You can use inheritance, really trouble-free. So everything is possible. You can store almost all Java types that are, it makes sense to be stored. So How does the object model look like? The object model is an object graph, which means an object graph. Yeah, you can store a single object, but you also can build up a huge and complex object graph where the objects are connected. So similar to a tree. You can use circular references, so everything is possible. Build any object model you like, so that fits for your application, and you can store it. The only thing you need is the first thing you need is a MicroStream instance. How does this look like? We have the application, we have a data storage, and then we need a root object, a MicroStream instance, and the root object, to the MicroStream instance, we need also a storage, and then we can add and store objects. That's very easy. To store objects, you only have to call one store method. So super simple. Every store is a single and atomic operation. It's an all or nothing operation, so it's transaction safe. And all stored objects are appended to the file storage. So we append the object in form of a binary code. So, and it's always appended. So every single store method call is appended to the file storage. How does it work? So let's add some objects to the root object. The root object is really comparable to a swing to a swing tree. So we can add some objects here and call the store method, and then a binary data is stored, appended to the file storage. Now let's add some more objects. Then we call a store method, and the binary data is stored, appended to the file storage. Let's add some more objects. We store it with a store method call, and it's appended, and so on. If you call a store method 1,000 times, then the object will be stored and appended 1,000 times. So your storage grows more and more, but this is not really a problem because we have this garbage collector that works on a file on a storage base. We also can, of course, change objects or update objects. How does it work? So you change some objects. You call a store method, and now we do not override the already stored objects. So this will never happen. We always append the stored objects appended to the file storage, also the updated objects. How does it work when you want to load objects, or mostly you will load subgraphs dynamically and restore the subgraph in memory? When you start your system initially, then MicroStream generates the root object, MicroStream instance, the root object, and then loads the entire object graph in the memory. But at this point, it's very important to mention that MicroStream will not load all objects into the memory. It only loads the object IDs into the memory. So MicroStream loads the object IDs and creates the entire object graph, but without the data. So this is why here in this slide, the object graph is black. So only the object IDs are loaded, and then if you access an object, if you call a get method, then MicroStream will load the objects dynamically from disk. So this is really similar to Hibernate lazy loading. So we can load any object at any time, and it will be loaded as soon as you call a get method automatically. So you don't have to create selects or something like that. So it's very simple. It's fully object oriented, and it works fully automatic behind the scenes. MicroStream cares really for everything. So we only have to call getter, and the subgraphs will load into the memory. Can you run in memory conflicts? No, actually, no, because the JVM cares for memory management. This is very convenient. But you can clear your lazy references at any time if you want to save memory. And you also can define timeouts for your subgraphs, for your lazy references, so to reduce the memory consumption. To search your object graph, you can use Streams API. You can also use GraphQL, and this also I mentioned already. If you use Streams API, then all of your queries will be executed in microseconds. This is the power of the JVM. This is the power of the Streams API. And this is also one reason why we call it MicroStream, because everything is micro here. Yeah, we can clear. You have full control of your lazy references. You can clear the lazy references anytime, and then MicroStream, will be able to use fresh memory again. What happens if your classes change? Then we have a legacy type mapping. So let's say here we have some objects, and we now want to change the classes. So let's add some fields, or delete some fields, or change types or something like that. Then this is no problem. Just do that. And when you start your application again, then you only have to store this changed objects. And as soon as you store the changed objects, then you will have two object versions in your storage. Then you have the latest version of your object, and you will have legacy objects in your storage. And so the MicroStream garbage collector can now remove the older versions from your storage, and you can configure that. So here we have some, hopefully, no, here in this slide. So we have some legacy objects, and with our garbage collector that runs behind the scenes, operates on a file storage and removes your legacy objects from your storage. And so this cleans up your storage and keeps your storage size small. With MicroStream, you also can parallel your I/O operations. So the more cores your hardware supports, the more channels you can use, which are actually just threads. So you can configure that, and so this will accelerate your I/O operations. You can use really everything that is available in the Java ecosystem. So you can use Lucene for full text search. You can use GraphQL as a query language. I mentioned Azul JVM. If you have huge memory sizes, then we recommend the OpenJ9 JVM, which is a little bit faster and is suited for bigger memory sizes. And if you have really big memory sizes, then you can use Azul. They are able to manage up to 20 terabyte RAM size without garbage collector pauses. I don't know. I've never tried this out, so play around. But these data are from Azul, and there are of course some rules, and there are also challenges with MicroStream because all technologies have pros and cons. And I also want to talk about the challenges. But one really important thing is you have to think a little bit different. Here on the left side, we have the traditional database server paradigm. With the traditional database server, your database is located on a remote server, on a remote database server. And if you want to query your database, your query will be executed on this remote database server. And your persistent data are also stored on this remote database server. With MicroStream, it's different. With MicroStream, your database is located within your application. It runs within your application embedded. So it's an in-memory database. Your object graph becomes your in-memory database. And your queries will be executed within your application. And this is the biggest difference. The database is in memory. The queries are executed within your Java application, and only the storage, the persistent storage data are stored in plain files or in a remote database server. And one of the most important questions we answer here in this slide is, do I need huge memory sizes? Is this mandatory? Do I have to load the entire database into the memory? And the question is no. You can do that, but it's not mandatory. So and it depends really on the use case. If you have a huge memory size and you have a small storage size, a small database size, let's say you have only 1 gigabyte database size and you have 32 gigabyte memory, and of course you can load the entire database into memory, and then everything runs in memory. It's super fast. Everything is executed in microseconds. But this concept maybe will not be suited for microservices, because you have to, after you have started your microservice, you have to load the entire database into the memory, and this is not suited for microservices, because startup time is very important. So if you have a monolithic application, you start it once and run it for years, then you can do that, of course. And on the right side, we see an approach that is used mostly. So you have a huge database size, and you only have a small RAM size, let's say 4 gigabyte RAM, and you have a terabyte database size. This is the most convenient case, and MicroStream works with this very, very good, and it's perfect. it's built for running such applications. Then you load only initially you only load some data which are really super important, and all the other data you will load on demand. And this concept or this approach is then also suited for microservices. There are also some architecture rules with MicroStream, or MicroStream is actually, or MicroStream as it is today, is a single JVM solution, storage solution. So you have, let's say, an application, one instance of your application, which means you run one node or your application in one node, and you have one data storage. That's perfect. So this MicroStream is built for this kind of like architecture. And you also can have one instance of your application, and you can store your data into multiple storages. So this is also seamlessly would work easily, and you won't have any problems. What is not possible with the standard version of MicroStream is you start multiple instances of your application or a microservice and store the data into one and the same data storage. Then you will run into concurrency issues on the writes. So don't do that. You can build up an architecture that will work. You can use Kafka for that, for instance. Then you can do that. But you have to, if you use the standard MicroStream as it is, then you mustn't do that. The question is also, do I have to care for memory management? The answer is no. It's fully managed by the JVM. You use lazy references, and you have fully control of your lazy references. So you can remove lazy references from the memory, and you can reload it anytime if you like. But you don't have to care for memory management. So it's everything done by the JVM, and it's managed by the garbage collector. Challenges, yeah, it's completely built for Java developers. So Java developers will be happy with MicroStream, hopefully, but C developers or Python developers are unfortunately currently out. So we have plans to port MicroStream to other development, to other programming languages, but currently it's not in progress. I mentioned it. It's a paradigm shift in database programming, so you have to think a little bit different. You have to think a little bit more like a Java programmer. Forget all database rules. That will be helpful. And of course, there is no support for SQL. You have to use Streams API or GraphQL to search your data. MicroStream is a storage engine, and it's not a database management system. So your application becomes the database management system. So the object graph becomes your in-memory database, and your application becomes the database management system, which means your business logic have to take control of everything that happens behind the scenes. So you have to care for validation, and you have to care for concurrency. And it's I think not really suited for DBAs, because SQL is not supported. Every 6 months we release a new MicroStream version. Currently we have the MicroStream version 6 and we are working on the version 7 currently. The roadmap is very clear. We're working on a MicroStream cluster that enables you to run distributed applications or microservices with MicroStream very easily. So we provide object graph replication. This is very interesting, and we will offer a cloud service that enables you to use MicroStream with some mouse clicks and build up a MicroStream cluster with only some mouse clicks. So you can build up such a cluster. Already today, but you have to do it for your own. And with MicroStream Cluster and Cloud, you can run it with only some mouse clicks. This is our goal. And the MicroStream serialization is, as a standalone serialization, is already available or will be available with the version 7. We're working on MicroStream for serverless functions also, that enables you to store your serverless function state and restore it very easily. We also will provide MicroStream for Kafka and work on further database connectors. And now Florian will show some code at last. The slides of the MicroStream cluster we can talk about later on also. Okay, that was the theory. I guess Florian can show you some code now.
All right, thanks, Marcus. So I'll just share my screen and show you where to start with MicroStream. All right. So this is our GitHub page, and I recommend that's the point where to start. So MicroStream is completely open source, so you can just go to our repository, the main repository, and there are the links to all interesting stuff like the documentation, the reference manual here. So there are different learners. I by myself like to browse through code and the documentation on demand. So a good starting point would be our demo project, which is also on our GitHub site, of course. It's called the bookstore demo, which mimics a book sales company's application and covers several aspects of a possible MicroStream application. So it's based on Spring Boot, but you can use Helidon or whatever framework you like to use as a base for your application, or plain Java. It's built with Maven and PNPM for the UI layer, because we have a small web interface within to show you, and a lot of stuff which you can use besides MicroStream or can seamlessly combine with MicroStream. So GraphQL, for example, or REST. We also used Lucene for full text search. And we covered the most common or most often asked topics of an application where MicroStream is used as a persistence layer. So we have concurrency in there, we have validation, the data layer, the data model design. Yeah, we can look a take a look. So Marcus already said it. We don't use any interfaces, or you don't have to extend a type or use annotations of any kind. Just write your Java POJOs or object as you used to. Just think in plain Java, and MicroStream will handle them fine. So as you can see, no annotations needed or clutter of any kind. And that's because MicroStream uses external handlers to do the serialization stuff. So you don't have to implement throwing stuff for serialization, like with the Java serialization in your business entity, but you can customize the handling with an external handler. You don't have to, because the generic handler will do just fine, but you can if you like to. So just design your application as is. Just take a look at the purchases, for example. So there you can see we have a read-write locked stripe. This is one example of an concurrency handling. We use re-enter read-write locks for that. You can use simple synchronization or whatever framework you like to, but you have to keep in mind that you have to handle the concurrency, because the application now is your database, and of course you have multiple users working on it, so therefore you have to worry about concurrency. But that's plain Java here as well. So there are a lot of aspects covered here. Like I said, full text search, connections to other frameworks, external access with GraphQL, bindings to UI layer. Just browse through the code, and you can get a gist how MicroStream application can be designed from scratch. So if you're not into browsing through a lot of code, you can use our examples, which are included in our main repository, and they are linked to as well from our documentation. So if you're reading about file systems or custom type handlers, for example, these examples are linked in our documentation, so you don't have to search this stuff again. So that's what I recommend to as a starting point. Of course, we have the Java docs online, and if you have any questions, just head over to Stack Overflow or to our discussions. We enable the discussions on our GitHub repository as well, so you can get in touch with us and ask any questions like just now. So I would like to use the time we have left to do a little Q&A if you have any questions. So just unmute, or I will watch the chat messages.
So people cannot actually talk and be heard unless we invite them to the stage. But yes, we look at the Q&A, or we can invite people to stage. Can you see the Q&A? Do you want me to do it for you? Well, there is a question there, but it's not a question. It's actually a link, right?
Yes, I added a link. And Florian, we can show the performance demo. This can be interesting. Please let me share the screen again.
Yeah, I can open it as well.
Yeah, you can open it. Sure. So on our website, you can find a performance demo. This is very interesting. Here we have a bookstore demo. So it's a bookstore. It's an online shop, and we have about 250 gigabyte data. We have two applications running. One application is written with written in Java, of course, and based on Hibernate and cache, and uses an Oracle database. The second application is written with MicroStream, no local cache, and also use Oracle database, 250 gigabyte of data. And you can see the query code, and you can see all the queries are executed up to sometimes 10, sometimes 100 times faster, and sometimes more than 1,000 times faster with Streams API, with Java Streams. And this is really incredible. And this proves that core Java, plain Java is really much more faster than JPA. So every single query is executed much faster. And with pure Java, you can really build the fastest database applications on the planet. So it's because memory is super fast, and Java is really, it's best suited for in-memory computing, searching big amount of data in memory, super fast. And the only thing missing in Java so far was really an engine that stores your objects fast and easily, persistently on disk. And this is what MicroStream does. So this MicroStream actually the only missing piece of puzzle in Java. And and please don't forget that we have worked really many years on improving the Hibernate tool. So we have worked on the query languages for JPA, for Hibernate. And so we are really JPA fans, but we are very convinced that the pure Java is much faster. Object-oriented programming is much more convenient and much more the Java way. And so this is why we believe that MicroStream is a very cool approach for Java developers.
So we have a couple of questions that showed up meanwhile.
Yeah.
Can you see them, or do you want me to read them aloud?
Where can I see them?
Under Q&A. Okay, I can also show them on stage, actually. This is sort of a cool feature that I see that they have. So this is a question there.
Yeah, I can see the questions, but it is really funny because they are translated automatically into German language, and this is what I said previously. It sometimes makes no sense. So it's,
I see them now. Okay.
So the first question is, do you have a demo with Spring Boot?
Yeah, the bookstore demo is based on Spring Boot, actually.
So the bookstore in your GitHub, right?
Yep.
And the other question says, it's from Sophia, does this mean traditional RDBMS databases is replaced by the binary image of an object graph inside the RDBMS? So basically we discard the traditional RDBMS databases that we have.
Yeah, that's true. So to get a step back, MicroStream not only stores data to relational databases. That's one option. MicroStream writes basically to everything which takes bytes. So you can write to disk, that's the fastest, or you can use blob stores in a cloud, the AWS S3, for example. You can write to streaming platforms, to Kafka, whatever takes bytes. And we support the old RDBMSs because of customers which already have licensed the database servers and want to use their features like the replication or the backup and stuff like that without losing to use the already bought licenses. But what MicroStream doesn't do is a mapping to any different schema. So we don't map to key value stores. We don't map to table structures in databases. We only write bytes which are converted from the JVM's heap. The bytes we write are very similar to the heap on a JVM, and that's why MicroStream is so fast, because we don't have to convert anything to a different schema. And so that's the gist of it. And but basically, yeah, the database server is replaced with a MicroStream application in the long run. If you want to migrate from a conventional database application, because your source of truth, your actual data moves from a foreign server to your application where it belongs, and you can manage it on a central point. And that's the idea behind MicroStream. Yeah.
So the next question says, so outside the Java app, how can we query the database?
You have to. There are two possibilities. So first one, we have a REST interface with a web client where you can query your storage data. That's more for development and debugging purposes. But if you want to offer a possibility to query your data from outside, just think core Java. What would you do with a plain Java application? You would open a REST endpoint, so you can use GraphQL, and therefore provide the access to the outside world, to third-party systems. MicroStream is just a storage engine. The rest is done with pure Java and Java framework of libraries of your choice. Yeah.
So I think you sort of answered maybe my question. Okay, I'll just ask my question and then we'll continue. But so you might have answered it, or you definitely touched it, but I wanted to just clarify some more. So let's say that you have a microservice, and it uses the MicroStream, but you have several instances.
Mhm.
So how do they share this data? So is it done by the binary image that is stored somewhere, and then every so often the other ones get updated?
Not yet. That's one point which you're working on. Currently, MicroStream is a one-to-one. So you have one storage for one JVM. What we're doing right now is an automatic replication where you can synchronize different instances or pods, or however you want to call it. They can share the data and synchronize the data. And this feature, you can do it by yourself right now with some communication layer. For example, use Kafka as an event platform and share your data. But it can be done, but it's a lot of work. So we decided to automate it and provide a replication and synchronization between JVMs. So you can combine it with the lazy loading and basically get a cluster with sharded data, if you like. And that's what we're currently working on. Yeah.
So this is the Lambda support that you have in your roadmap?
Yeah. The Lambda idea is a bit of a different animal. So we want to extend the AWS Lambdas to get a better stateful functions as a service with MicroStream, and to share data between the lambdas. And that's the idea behind it. Yeah.
Okay, sounds good. Here is another question. How do we scale? We'll have n replicas of storage.
Yeah, that's basically the same
Yeah.
here with the replication. Yeah. So if you use our application, you're not limited anymore to a certain amount of machines. Yeah.
Okay, so I don't see any more question coming. Is there a way to ask you questions if somebody thinks of a question after the fact, after the presentation?
Yeah, sure. Just head over to our GitHub page. The discussions are open. We are monitoring Stack Overflow. That's the best way to get in touch with our team. Yeah.
Great. Thank you very much. Anything that you would like to conclude with?
Yeah, perhaps it's interesting to add that MicroStream is not a prototype or work in progress. It's already used by huge projects and companies. We have, for instance, more and more projects at the Alliance insurance company in Germany and other countries. It's more and more big companies are interested in using MicroStream and evaluate MicroStream. So check it out, and we're really keen on hearing what you think about MicroStream, and also if you have concerns or any doubts, tell us and send us your opinion. Yeah, this is great motivation for our team, and we would be happy if MicroStream would help you to build really super fast applications and build great applications. Thanks for having us. It was really great, and hopefully next time on site in Jacksonville.